Hello students, welcome to the second part of making the velocity analysis in mechanisms by using the instantaneous center method. In the first part we have seen the fundamentals of the instantaneous center, what instantaneous center is, how many instantaneous centers will be there in a mechanism, how they are located and all those things. In this part we will see the types of instantaneous centers and how they can be located by visual inspection and other methods. Now mainly there are two types of instantaneous centers. First category is the primary instantaneous centers. Under that we have fixed instantaneous center and permanent instantaneous center. And in the second category, which are known as secondary instantaneous centers, we have neither fixed nor permanent instantaneous centers. So in all mechanism we will have three types of instantaneous centers: the fixed instantaneous centers, the permanent instantaneous centers, and neither fixed nor permanent instantaneous centers. Now let us see what are these different types of instantaneous centers are. Therefore the figure. Now this is a figure which shows a 4-bar mechanism having 4 links, and we know how to calculate the number of instantaneous centers in a mechanism. This we have seen in the previous part, that is part 1. So using this formula you can calculate the total number of instantaneous centers for this 4-bar mechanism. So there are 4 links, substitute n equal to 4 and you get number of instantaneous centers n equal to 6. Now just by visual inspection we can locate the fixed instantaneous centers. So in this mechanism I12 and I14 are the fixed instantaneous centers. Now as you can see here, link number 1 is fixed and the instantaneous center I14 is between link number 1 and link number 4. Similarly, instantaneous center I12 is between fixed link 1 and rotating link 2, that is moving link 2. Now as whatever may be the position of link 4 or link 2, as these two links are attached to the fixed link 1, so the pin joint here at A, similarly the pin joint here at D will have the fixed instantaneous centers. Whatever may be the position of link 4 or link 2, the position of I14 and I12 will not change. They will be always attached to this point A and point D. They never change their positions. That is why they are called as fixed instantaneous centers. So I14 and I12 are the fixed instantaneous centers. So normally they pair with the fixed link and moving link. That is, for example, between link 1 and link 4. Link 1 is fixed and link 4 is moving, and link 1 is fixed and link 2 is moving. So here at D we have the fixed instantaneous center. Now in this case we have located just by inspection the permanent instantaneous centers. What are those? Those are I23 and I34. I23 and I34. So I34 represents the instantaneous center between link 3 and link 4, and I23 is nothing but the instantaneous center of rotation of link 3 with respect to link 2 or link 2 with respect to link 3. So this joint B and C, it is permanent, that is joint between link 4 and link 3 here at B. Similarly the joint between link 3 and link 2 here at C, they are permanent. So at these pin joints we have the instantaneous center of rotation between link 3 and link 4 I34, between link 3 and link 2 I23. So these two instantaneous centers are called as permanent instantaneous centers. but they will move, they are not fixed. So if the link 3 comes here, the I13, I34 as well as I23 also, they change their position, but I14 and I12 they will never change their position. Okay. So permanent, they are fixed to these pin joints here, but they can move. And third type of instantaneous centers known as neither fixed nor permanent instantaneous centers. Now these two instantaneous centers, that is I13 and I24, which are neither fixed nor permanent, cannot be located by visual inspection. So here this is I24 and I13. Then how these instantaneous centers are located? Neither fixed nor permanent. So here it is the permanent instantaneous center, fixed instantaneous center, and fixed instantaneous center. This is neither fixed nor permanent, neither fixed nor permanent. Now how to locate I13 and I24 instantaneous centers? These two instantaneous. What is the procedure to locate these instantaneous centers? We will see. Now, before locating those neither fixed nor permanent instantaneous centers, let us have understanding of the instantaneous center for various situations. Like here there is a turning pair between link 1 and link 2. So here there is joint here between link 1 and link 2. Now wherever there is joint between link 1 and link 2, there lies the instantaneous center. So as this is between link 1 and link 2, it is denoted by I12, instantaneous center of rotation of link 2 with respect to link 1. Maybe say link 1 is fixed here. Similarly, there is a ball, say, which rolls on this surface without slipping, and let us assume that this is link 1 which is fixed and this is rolling. Say it rolls in this counterclockwise direction. Now what is the instantaneous center of rotation in this situation? Now to locate the instantaneous center of rotation of this body which is rolling on this fixed link, say in this case in the counterclockwise direction, let us consider 2 points A and B in this body. Now let us say this is the direction of velocity of point A and this is the direction of velocity of point B, that is VB and VA. Now draw the perpendiculars from point A and point B. Perpendicular means perpendicular to the velocity vectors. So this is the perpendicular to velocity vector VA and this is the perpendicular to velocity vector VB, and these two will intersect here at the point of contact between the roller, or it may be ball also even, and the fixed link here. So I12 will be the instantaneous center of rotation of this moving ball on the which moves on this flat surface, say, which is fixed link. Now always whenever a body like this which is in contact with the another link, and if it rolls without slipping, the point of contact between the two links, remember the point of contact between the two links will be the instantaneous center of rotation. Now let us consider this case which is a sliding pair. So link 1 is there which is fixed and link 2 a slider. Let us say this is moving in the left direction. Now in order to locate or know the instantaneous center of rotation of link 2 with respect to link 1, again let us consider 2 points A and B in this body, moving body, that is slider, and this is the velocity vector of point A and this is the velocity vector of point B, and if you draw the perpendiculars from these two vectors A and BB, they never meet, they go parallel to each other. So hence the instantaneous center of rotation of a body which is moving in a straight line on a fixed link will have the instantaneous center of rotation at infinity. So if slider is there and if it is moving on a fixed link, its instantaneous center with respect to the fixed link will lie at infinity. This you should remember. Now let us consider this case. This is a concave surface and a body is there which is moving inside this concave surface. Let us say this concave surface is fixed, and let us say this body that is linked to, which is moving in this counterclockwise direction. Now in order to identify the instantaneous center of rotation of link 2 with respect to link 1, again consider 2 points A and B on body 2, that is link 2, and these two are the velocity vectors of point A, and this is with respect to point B. Now draw the perpendiculars from the velocity vector BA, this one, and velocity vector BB, this one. They will intersect at this point, which is the instantaneous center of rotation of this link 2 with respect to this link 1. That is how whenever a body moves inside a concave surface, the instantaneous center of rotation is identified. Another case where a body is there which is moving on the circumference of this convex surface, and this convex surface is fixed, link 1 is fixed and link 2 is moving on this. Now again, say this is moving in the counterclockwise direction, and in order to identify or locate the instantaneous center of rotation of this link 2 with respect to link 1, consider 2 points on this body, A and B. Let these be the directions of velocities of point A and point B. Now as usual, draw the perpendiculars from the point A and point B. Perpendiculars means perpendicular to these vectors, and these two will intersect at this particular point. Maybe sometimes the center of this only. So that is how whenever a second body moving over the circular type of body which is fixed, that the instantaneous center of rotation is fixed. Now Arnold-Kennedy theorem, very important as far as the location or fixing of the instantaneous centers in a given mechanism is concerned. What this theorem says, what this Kennedy's theorem says, if three bodies move relative to each other, if three rigid bodies move relative to each other, then they have three instantaneous centers that lie on a straight line. I repeat, if there are three bodies which are having relative motion with respect to each other, and then they will have three instantaneous centers that lie on a straight line. Now let us look a little bit more into this statement of the Kennedy's theorem. Now let us assume that there are three links here. Link 1, the fixed link, link 2 and link 3. Now for this particular configuration of three linkages, the instantaneous center of rotation between link 1 and link 2 is here, I12. The instantaneous center of rotation between link 3 and link 1 is here at this joint, I13. The fixed instantaneous. Permanent instantaneous center is here, I23, which lies at the joint between link 2 and link 3. And here what the Kennedy's theorem says, if there are three rigid bodies having relative motion with respect to each other, and all the three instantaneous centers must lie in a straight line. So here there are three links having relative motion with respect to each other, but these three are not in a line. How come? And let us consider this point B, very important. Now the velocity of point B at this instant is perpendicular to this link. Similarly, if you take point B on this link, that is link 3, again this will have velocity perpendicular to link 3. So here when you take point P on link 2, its direction, velocity direction is like this, perpendicular to link 2, and when you consider point B on link 3, its velocity direction is perpendicular to link 3. Now, very interesting situation. Same point having two different directions. Strange. How come? It is not possible. At the same point B having two different directions of velocities. Not possible. Now let us look into that. So here in this, let us shift the position of the point B towards the fixed string, and this is the direction of the velocity vectors. Again, let us move point B closer to link 1, and these are the directions of the velocities. And here in this fourth figure, let us say link 2 and link 3, they are in line with link 1, and the point B will have a single direction VB. Now you can see three instantaneous centers, I12, I23 and I13. They are all lying in a single straight line. That is what the Kennedy's theorem is, and that is the proof of the Kennedy's theorem. Okay. Now let us have a look at the method of locating the instantaneous centers in a mechanism. Already we have noted this formula, which is used to calculate the total number of instantaneous centers in a mechanism. This is the 4-bar linkage mechanism. 4 links are there, so small n equal to 4 should be small n. So if you substitute that, here total number of instantaneous centers will be 6. Now what are those different instantaneous centers? It is a simple method or rule is there. Prepare a table like this, link numbers 1, 2, 3, 4, and in these cells we will write the different instantaneous centers. First we shall fill this column. Take link number 1 at a time and make combination with link 2, link 3, link 4, keeping taking link 1 at a time and making combination with remaining links 2, 3 and 4. We get 1, 2 here, 1, 3 here, 1, 4 here. Okay. Similarly, take link 2 and make combination with remaining 2 links 3 and 4, 2, 3, 2, 4. Then coming to the third link, make a combination with the remaining link 4. We will get 3, 4. I12, I13, I14, I23, I24 and I34. So that is how different instantaneous centers can be listed. I repeat, prepare this table, write down the number of links. Here in this there are 4 links, 1, 2, 3 and 4, and in these columns we will fill the number of instantaneous centers. So here take link number 1, make a combination of link 1 other links 1, 2, 1, 3, 1, 4, 1, 2, 1, 3, 1, 4. Then take, come to link 2, make a combination of link 2 with remaining 2 links 3 and 4, 2, 3, 2, 4, 2, 3, 2, 4. Then come to 3, make a combination with one link, that is 4, 3, 4. So no more combinations are possible. So here 1, 2, 3, 4, 5, 6. So there are total 6 number of instantaneous centers for this given 4-bar mechanism. Okay. Now let us look at the various instantaneous centers as far as this 4-bar mechanism is concerned. Now let us first locate the fixed and the permanent instantaneous center just by inspection. Now for this 4-bar mechanism has 4 turning pairs at A, B, C and D. So we have four primary, including fixed and permanent instantaneous centers located at centers of the pin joints, that is here, 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 here. So here between link 1 and link 2 we have I12, between link 2 and 3 we will have I23, between link 3 and link 4 here at B we will have I34, and here between link 4 and link 1 or between link 1 and link 4 we will have I14. So in this I12 and I14, I12 and I14 are the fixed instantaneous centers, and I23 and I34 are permanent instantaneous. Now in this table, scratch down all those which have been marked, located, like I12 is located, I23 is located, I14 is located, and I24 is located. Now which are remaining? I13 and I34. Now let us see how I13 and I34 can be located. So these are the different instantaneous centers. Now to locate neither fixed nor permanent instantaneous centers, which are the secondary instantaneous centers, let us follow the circle diagram. So draw the circle first, and on this circle mark points which are equal to number of links in a mechanism. So we have 4-bar mechanism and there are 4 links in the mechanism. So on the circumference of the circle mark 4 points, preferably at equidistance. This represents link number 1, link number 2, link number 3 and link number 4. Now join points by solid lines to show that these centers are already formed. So that means if I join link 1 and link 2, I12 is located. Similarly, if I join 1 and 4, it is understood that the instantaneous center between link 1 and 4 is located. So between 2 and 3, I23, it is located. Similarly, between link 3 and link 4, if you connect this by solid line, so it indicates that already I34 instantaneous center between link 3 and link 4 is already located. Right. Now, to locate the remaining instantaneous centers, which are those I13 and I24. I13 and I24 can be located again by using this circle diagram. So already in the previous slide we have seen this. So this is the way of representing the permanent and the fixed instantaneous centers. I12, I14 are the permanent instantaneous centers, and I23 and I34 are the fixed instantaneous centers. Now we have to locate the instantaneous center I13. How it will be located? Now in order to locate the instantaneous center I13, connect links 1 and 3 on the circle diagram. Connect link 1 and link 3 on the circle diagram. Now this should be dotted line or dashed line. Okay. So the dashed line means the neither fixed nor permanent instantaneous center. Now by connecting link 1 and link 3, you get 2 triangles. What are those? 1, 4, 3, 1, 4, 3, one triangle, and 1, 2, 3, another triangle. So these two are similar triangles. By connecting link 1 and link 3, we get triangles 1, 4, 3 and 1, 2, 3. Now the instantaneous center I13 will lie on the intersection of I14 and I34. Instantaneous center I14 and I34. Similarly, another line which consists of two instantaneous centers I12 and I23. So I13 will lie on the intersection of instantaneous centers I14, I34 and I12 and I23. Similarly, the last instantaneous center I24 can be located by connecting the links 2 and 4 on the circle diagram. So that is how here the instantaneous center I13 is located. So I13 lies on the intersection of instantaneous centers I14, I34. I14 is here, I34 here, and other line consisting of I13 is I12, I23, I12, I23. Extend these lines and they will intersect here and you will get instantaneous center I13. I will repeat the location of I13. So I13 lies on the intersection of instantaneous centers I14 and I34. I14 is here, I34 is here. Extend this line. And other set of instantaneous centers are I12, I23. I12 is here, I23 is here. Extend this line. And these two will intersect here, and that is the I13 instantaneous center. That is instantaneous center of rotation of link 3 with respect to link 1. Now similarly, the last one I24 can be located by connecting link 2 and link 4. When you connect these two links 2 and 4, it gives rise to two similar tangles 214, 234, 214 and 234. And I24 lies on the intersection of I12 and I14. Similarly, I23 and I34. I23 and I34. So I24 is this. So if you connect the instantaneous centers I12, I14, I12 is here, I14 is here. So on this line the third instantaneous center will lie, so here. And similarly we have I23 and I34, I23 and I34 from this you draw a line, and these two will intersect at this instantaneous center I24. So that is how all the instantaneous centers of a mechanism are located by Kennedy's theorem and also by using this circle diagram. Now let us take an example. This is 4-bar mechanism having fixed link AD 600 mm, crank AB 300 mm, the coupler 360 mm and the output link 360 mm. So we have to locate all the instantaneous centers and find the angular velocity of link BC. Let us do it. Now since the mechanism consists of 4 links, that is small n equal to 4, therefore the number of instantaneous centers for this mechanism is 6. By using this relation we can easily determine. For a 4-bar mechanism shown here, the bookkeeping table, this is a table, may be drawn as discussed earlier to identify the total number of instantaneous centers I12, I13, I14, I23, I24, I34. So I12, I13, I14, I23, I24 and I34, these are the 6 instantaneous centers. Now next step is to locate the fixed and permanent instantaneous centers by inspection. So here at the joints A, then B, C and D, we have the instantaneous centers. For example, between link 1 and link 2 we have I12, between link 1 and link 4 I14. These are fixed instantaneous centers. And similarly between 2 and 3 we have I23, and between 3 and 4 we have I34. These two are the permanent instantaneous centers. Now job is to locate I13 and I24. So following the method explained earlier, we can locate the remaining 2 instantaneous centers which are neither permanent nor fixed instantaneous centers by the Kennedy's theorem and this circle diagram. Locate the remaining neither fixed nor permanent instantaneous centers by Arnold-Kennedy theorem. This is done by circle diagram as shown in figure here. Mark 4 points equal to the number of links in a mechanism like 1, 2, 3, 4 on the circle, 1, 2, 3, 4 on the circle. Join points 1 to 2, 2 to 3, 3 to 4 and 4 to 1 to indicate the instantaneous centers already located, that is I12, I12, I23, I34 and I14. These have been already located. Now next, join 1 to 3, 1 to 3 to form two triangles 1, 2, 3, 3, 4, 1, 1, 2, 3, 3, 4, 1, 1, 2, 3 and 3, 4, 1, 1, 2, 3 and 3, 4, 1. Now the side 1, 3 common to both triangles, 1, 3 common to both triangles, 3, 4, 1 and 1, 2, 3 is responsible for completing the two triangles. Therefore, the instantaneous center I13 lies on the intersection of the lines joining the points I12, I23 and I34 and I14 as shown in figure here. So that means I13 will lie on the intersection of the lines containing I14, I43 and I12 and I23. So thus the center I13 is located. Mark the number 5. So this is fifth instantaneous center, it has been marked. Now join link 2 and link 4 to complete two triangles 2, 3, 4 and 1, 2, 4, 1, 2, 4 or 2, 1, 4. The side 2, 4 is common to both triangles and is responsible for completing the two triangles. Therefore, I24 lies on the intersection of I24 lies on the intersection of I12, I23 and I43 or I34 and I14. So on the intersection of I12, I23 and I34 and I14, I24 will lie. Now thus all the 6 instantaneous centers have been located. Now coming to the determination of angular velocity of the link BC, omega BC, since B is also a point on link BC, therefore the velocity of point P on link BC will be equal to PB equal to omega BC into I13 into BC. So from the measurement, the distance of instantaneous center I13 from point B is 500 mm. So substituting this, we will get the angular velocity of link BC, that is 6.282 radians per second. So students, that is the end of the part 2, and we will see in part 3 with another example of a slider crank mechanism, and we will see how the velocity analysis can be made by using the instantaneous center. Thank you.